Okay, we just got just a few ones here, but this is problems 27 through 29. So we'll do 27 and 29. Basically, it shows how the Fibonacci sequence can be related to the Pythagorean triple. So let's go ahead and write out the Fibonacci sequence again. So it's 1 and 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 34. 55. 89. Okay, so those are the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. Now, let's read what it says. Suppose that we choose any 4 successive terms of the Fibonacci sequence. So we're going to choose, for 27, we're going to choose, well, they're choosing it for is 1, 1, 2, 3. Okay, so those are the 4 successive terms. Multiply the first and the fourth. So step A is multiply the first times the fourth, which is 3. 1 times 3. Double the product of the second and third. So the second and third are 1, 2, and we doubled it. So we multiply it by 2, and that gives us 4. Add the squares of the second and third. So we take 3 squared plus 4 squared, and we get, that's 9 plus 16 is equal to 25. Three results obtained for a Pythagorean triple. So the triple comes from, if you take the square root of that number, you get 5. Now, this one's going to be automatic because the just the way that if we square that plus that square that one, then that's of course going to be the hypotenuse anyway, but it comes out to be an even number. I guess it's an important thing. So let's try 3, 2, 3, 5, 8. So what do? We take the first times the fourth. That's 16. We take the second times the third, and we double it. So that's 15 times 2 is 30. And then we take 16 squared plus 30 squared. 16 squared plus 30 squared, and we take the square root of that. When you do that, you get 1156. If you take the square root of 1156, you get 1156 square root, you get 34. So 6, 30, and 34 are Pythagorean triples. Let's try a bigger one just for the heck of it. So we're going to try, this is not one of the problems that's due, but let's try 21, 34, 55, 89. So we take 21 times 89. 21 times 89, that's 1869. We take the two middle numbers, 34 and 55, and double it. 34 times 55 times 2 is 3,740. And then we take 1,869 squared plus 3,740 squared, 1,869 squared plus 3,740 squared, which is a big long number here, 1748061. Take the square root of that, and we get 4,181. So this is also another Pythagorean triple. 1869, 3740, and 4181. So it does work. Okay, pretty cool. Now, the last thing we're going to look at, we're going to see this again in second semester. It's called Pascal's triangle. And you start off with ones in a triangle, and then you say, okay, 1 plus 1 is 2. So you add these two together. And on the outer, you always put 1. So the outside of the triangle, 1s. And you end up with one additional element per row. So we start with 1, 2, 3, 4. So you take these two numbers, add them together, and you get 3. And 2 plus 1 is 3. We have 1 on either side. 1 plus 3 is 4. 1 plus 3 is 4. 3 plus 3 is 6. 1 on the other side. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we add these again. 1 plus 3 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. So that's Pascal's triangle. And it's important in probability, as you'll see. Now it says if we write this in a different form, where we take this as a row, so we have 1, 1, 1, 1, 1, 1, 1, and then this is the next one. You get 1, 2, 3, 4, 5, 6. And then the next, this diagonal becomes 1, 3, 6, 10, 15. This diagonal becomes 1, 4, 10, 20. This diagonal becomes 1, 5, 15. This diagonal becomes 1, 6, and then we have the final one. So we've kind of put it at a slightly different angle. The sums across along the diagonals is indicated by dashed lines are found. There's an interesting occurrence. So let me just put some dashed lines in here. So what we're talking about is this diagonal, this diagonal, this diagonal, this diagonal, this one, this one, so that would be there, this one, this one, this one, this one. Okay. So if we add these numbers together, we get, put these in blue, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 plus 1 is 5, 1 plus 4 plus 3 is 8, 1 plus 5 is 6, 6, 13, 6 plus 10 is 16, plus 4 is 20. Oh, I guess that one did get it counted in there. No, it shouldn't. No, then it doesn't work after that, apparently. Okay, so these apparently don't make any sense, so we just get rid of those. If you had more terms, obviously, or I guess that at least you're halfway on this thing, then it works. Otherwise, it doesn't work. So if I had another row, what I would have, let me just add one more row more than they had. So we have 1s on the outside. 1 plus 6 is 7, 21, 35 plus 20 is 35, 35 again, you get 21. You see it's symmetric. So if I were to write those in there, 1, 7, 21, 35, 35, 21, 7, 1. So if I were to take this diagonal, I'd have 4 plus 10 plus 6 plus 1, which would be end up with 21. So that doesn't work. And at the next row, you'd end up with, I guess the next one would add up to be 34.